have you eaten a red apple and a green apple? Drop a comment down below which tasted better for you. I'm really excited to read your comments. In this video, I'm actually going to prove that you were dreaming everything up. It was all an imagination. It didn't actually happen. All apples are all the same color. There aren't apples of different colors. I'm going to give you a mathematical proof of this fact. So let's just dive right into it. It's a proof by the principle of mathematical induction. And even if you don't know what that is, you'll see it develop as we go through the video. So what we're going to do is we're going to prove that if we have, so here's the proof, there's the statement, now we're going to do the proof, is that if we have n apples, they are all of the same color. Okay, so if we have n apples, n being in a whole number, it could be 1, 2, 3, etc., then they are all of the same color. Now what I'm going to do is I'm going to prove this step by step. This is the principle of mathematical induction. I'm going to prove it first of all for n equals to 1. So if we have in general n equals 1, then n equals 2, then n equals 3, etc., we're going to keep proving it. Okay? So for n equals 1, if we have one apple, are they all of the same color? Well, yes. If it's just one apple, then of course there's only one apple. So everything's of the same color. This is what we call the base case of the induction, and it is satisfied. Now what I'm going to do is I'm going to prove that if I have n apples, if the statement is true for n, it is true for n plus 1. Okay, so that is the base case. This is now called the induction hypothesis. If it's true for n, then it's true for n plus 1. So by repeating this, you get that it's true for any n. Okay, so combined with the base case, we prove the statement for all n. So if the statement is true for n apples, okay, so if the statement is true for n apples, then it is true for n plus 1 apples. And if you're thinking about, I have eaten a green apple and a red apple before, I'm just telling you that you're misremembering, okay? So I'm going to prove to you that you're wrong. So how is this going to work? Well, basically, let's take n plus 1 apples, okay? So I'm just going to literally sort of visualize them. We take n plus 1 apples, kind of something like this. This is just a picture, okay? Just a pictorial diagram. Now, because the statement is true for n apples, right? If we take, for example, a bunch of n apples out of the n plus 1, okay? So I'm just going to sort of do something like this. By the induction hypothesis, because we've already shown, suppose we're assuming it's true for n apples, all these n apples have to have the same color, okay? These n out of the n plus 1 apples. But then we can do the same with another bunch of apples. So here I've drawn one bunch of n apples. Now I can sort of draw another bunch of n apples, okay? I can draw another bunch of n apples, something like this. And the statement's also true. All those n apples have to have the same color. That's by the assumption. But therefore, if those n apples have the same color, and the first bunch of n apples have the same color, there's an overlap, so therefore, all the apples have to have the same color. So what we've done is, we've shown that if the statement is true for n, it's true for n plus 1, and therefore, any bunch of n apples that I give you, they must have the same color. There's no way of producing a red apple and a green apple. It must have been your imagination. Now, am I wrong? Am I tricking you? Where am I tricking you? What's going on? Drop a comment down below what you think. I'm really excited to see your comments, and also tell me which kind of apples do you like. And the same argument works for a whole bunch of things. It works for grapes. There aren't red grapes, green grapes, black grapes. There's only one color. All grapes have the same color. But tell me which color of grapes you like. I'm excited to read your comments, excited to hear what you think about this mathematical proof by induction. And for our next video, if you really love this video, I'm going to direct you to another video here. It's a beautiful video about pi, about proving that pi is greater than 3, straight from the definition, accessible for everyone. It's going to pop up on the screen here. I'll see you there, but don't forget to drop a comment down on this video before you go there.